So for this part of this question, we're told that for the same signal emitted by a radio antenna, observer A measures its intensity to be 16 times the intensity measured by observer B. So let's break that down. So since it's the same signal, P is going to be the same, right? But we're saying that some observer A is measuring some intensity I, and observer B is measuring 1/16 of that, right? So because this one's 16 times bigger. Then we're then told, or rather asked, the distance of observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna? So again, let's remember that our distance from radio antenna is represented by a variable r. So what we're looking for is basically ratio of distance from antenna to observer A over distance from antenna to observer B, right? So how can we find that? Well, again, we can use this formula that it gave us, and what we're going to do is basically solve for r when I is I and when the intensity is 1/16 of I. So let me just show you what I mean. So for observer A, we have, again, I, that's the intensity here. We just assign variable I. Again, it doesn't actually matter what the number is. It'll all cancel out in the end. So like, it doesn't matter that we don't know the true magnitudes of these. What matters is just their ratio here. So I is equal to P 4 pi r squared. So let's solve for r here, right? We want r in terms of all the other variables. So let's just start by, again, so we have a fraction. We don't like fractions like this, so let's just multiply both sides by 4 pi r squared to sort of get it all in one line, right? 4 pi r squared. So that'll give us 4 pi r squared. I is equal to p, right? Because these two will cancel out, okay? Now, what do we want? We want r, right? So how do we get r by itself? Well, what we can do is we can just divide both sides by everything that isn't r over here, right? So we can actually divide both sides by 4 pi I, right? Because, let me write that down, 4 pi I, because the 4 will cancel out, the pi will cancel out, the I will cancel out, and then we'll just have our r left. So we will then know that r squared is equal to p over 4 pi I, right? So at this point, to solve for r, you just take the square root, right? So we can say r for A, right? Ra for observer A, the distance is going to be equal to the square root of p over 4 pi I. Okay, so we have that. Now let's do the same sort of thing for observer B. So let's do observer B over here. So for observer B, the intensity is equal to 1/16 I, right? So then we can set 1/16 I. Again, I'm just using this formula right here, right? So we were told that the intensity is 1/16, so I'm saying 1/16 I, because that was the intensity we chose for observer A, is equal to P over 4 pi r squared. So what we're going to do now is we're going to do the same thing over here to find the RB, and then we're just going to put one over the other and solve. So here, again, we want to isolate r. How can we do it? Well, again, we have this fraction here. Let's try to, get rid of that a little bit. So let's just, again, just like we did in the other example, multiply both sides by 4 pi r squared. Don't have enough space there, but so it would be now 4 pi r squared times 1/16 I is equal to p. So let me just rearrange this a little bit. So this part, so this is 4 pi r squared. This is equal to, well, when you're multiplying those two together, right, this is equal to I over 16 equals p. And then if you multiply this together, so you have 4 pi r squared I over 16 is equal to p. So we're here and we want to solve for r, just like we solved for r over here. So how can we get r by itself? Well, first let's just multiply by 16. Again, get rid of this fraction. So multiply both sides by 16. So this will cancel out. So you have 4 pi r squared I is equal to 16p. Okay, so we have it all in one line. Now let's just isolate r. Let's again, just like we did in the other example, divide by 4 pi I, so the 4 pi and I cancel out, so you have just the r squared. So r squared is equal to 16p over 4 pi I, and finally just take the square root, right? So rb is equal to the square root of 16p over 4 pi I. Now, let's take these two pieces over here and figure out what the actual answer for this problem is. So a little bit before we do that, let me write this a little bit differently. So RA equals. So when you take the square root of a fraction, it's equal to the square root of the top over the square root of the bottom. So let me just write it that way. Let me just write this as square root of p over square root of 4 pi I. Let me do the same thing with this one, right, with the RB. So RB is equal to the square root of 16p. So the square root of 16p, well, how you take square roots of numbers and variables like this is the square root of 16p is equal to the square root of 16 times the square root of p. So what's the square root of 16? 4. So this is actually 4 times, we don't know what the square root of p is, so we just write square root of p over the square root of 4 pi I. All right, so we've gotten this far. Now let's just go ahead and put one over the other, right? So RA over RB is equal to square root of p over, so RA, right? Square root of p over square root of 4 pi I. I know this looks disgusting, but just bear with me for a little bit. We're about to get a lot of satisfying cancellation. Over 4 square root of p, right? Again, I'm just plugging in RB. Square root of p over square root of 4 pi I. So how do we divide fractions? Flip the second and multiply, right? So that'll be square root of p over square root of 4 pi I times the reciprocal of that, right? So times the square root of 4 pi I over 4 square root of pi. And now what do we get? This cancels with that. The square root of pi cancels with the square root of pi here. So we have just 1 on the top, right? Because we have, all this canceled out, so we just have 1 left on top. And all those cancel out, we just have 4 on the bottom. So 1/4 is your ratio between RA and RB, which is answer choice